Okay, integration by part. Integration by part we use when two functions are being multiplied. Now, for example, let's say I got the integration of u dot v dx. Now, there is a law, integration law. How we use that one? U is here, integration of v dx minus integration of u dash. U dash is the differential of the u. Then I just put that sign. Integration of, now this one we have to do that one separate. Integration of v dx. So I just close that bit. And then the dx. So this dx is for that one, and this is for that. This is, you will not see this bracket actually, but I just put that one just for simplification. U is the function and v is the function as well. U dot dash is the derivative. So u dash is the derivative. That one is a derivative of the function u. Okay. Now, how do we choose which one is u, which one is v? Like before, when we did a product rule for the differentiation, is totally different. You can choose whichever u, whichever v. Here, no, there are rules. And the rule is like this. L-I-A-T-E, liate. So that's how I remember. Log, inverse, algebraic fractions, trig, exponential. That's the order of selecting the u. So you will select, if it's log, you select that one as u. If it's inverse, you select that one as u. If that's the first thing, first you need to do that one. So log is going to be the first. If there's a log inverse, log is going to be u, inverse is going to be v. If there is trig and log, log is going to be the u and trig is going to be the v. If it's algebraic fraction and exponential, algebraic is u and exponential is going to be v. Okay, so let's do one question. And then we have a look. Let's say I need to integrate x dot cos x d of x. Now, I need to select which one is u, which one is v. Also remember, u is the kind of thing that will kind of disappear, that will simplify. That's the easy one. So I look at that one. What is this? This is algebraic, and this is trig. So which one is the high in the list? Algebraic is the high in the list. So I'm gonna say my u is an x. Okay, and obviously then v is the cos x. Now, then what I'm going to do is I will differentiate the u. And I will integrate the v. So differentiate the u and integrate the v. Okay, let's differentiate this one. So find me when you differentiate, that will give you the u dash, yeah, u dash. Actually, let me do a proper way, and then you can call it d. So du over dx equals to d over dx of the x. And what's d over dx of the x? It's just a 1. So you can call it du over dx. It's actually a u dash, yeah, which is that bit. Now I need to integrate the v. Excuse me. So integrate the v and integrate this v, this side. What's the integral of cos x? Integral of cos x is sin x, yeah? Derivative is minus. Okay. Now, obviously, there's a plus c, but I'm not writing plus c. I write in the end straight away. So that is actually this bit. So now we know this thing is just a 1 And we know this thing is just a sine x. Another thing, if you do it wrong, if you select the u and the v wrong, you will figure out yourself. The reason is because the question is never going to end. It will go on and on and on and on and on. And then you can straight away figure out you've done u and v other way around. Okay, now I'm going to put that in this formula. So if I integrate that one, it's supposed to be, let me write it down neatly. X cos x. Now I need to get the x out here, and then I need to do the cos x dx minus u dash. U dash is just, I already done that one, which is just a 1, so I can put that one here. And then in this box, rather we do the cos x dx, close the box, and there was another dx here. Okay, now let's do this one. X is just an x. This thing we already calculated, it's a sine x. So dot sine x minus, this will be, yeah, that's just 1. 1 comes out. Yeah, constant. We don't do. Now this one, I've done that one. This one is sine x. Yeah. Now I need to do this one is sorted. This is done. But this one I have to do. What's the integration of sine x? It's minus cos x. Okay, and there's a minus, and then there's another minus. Minus makes a positive. So I can just cross that one, put it like that. Do not forget the plus c. That's it. This is how we do integration by part. Now, this is the most important thing here is that bit. You need to know this bit. This is super important. Log, inverse, algebraic, trig, exponential. If I have chosen other way around, what happened is that will, instead of 1, it will become x squared over 2. Yeah. And then I won't be able to finish it. Next time it will become x cubed. And then I won't be able to finish. Then I have to do again and then again and then again. So I won't be able to finish that bit. Okay, let's do one other question. Okay, I'm just going to clear that one. I will upload it online for you guys. Same recording. So ln x over x squared. Let's say, how do we integrate ln x over x squared? Now, to do this one, we need to select the u and the v. Now, if we have a look, this can also be written as ln x dot 1 over x squared dx. Yeah. You can't just cross the x and the x. You can't do that one because there's an ln attached to that one. Okay. Now, ln is a natural log. Now, I need to select the u and the v. According to that one, the u is a log, and log comes first, and then obviously second one, algebraic is here, so that's going to be v. Okay. So now u is ln x, and v is 1 over x squared. 1 over x squared, can I also write 1 over x squared as x to the power minus 2, rule of indices. Now, I need to do the same. I got the u. Differentiate the u. Differentiate the u with respect to x. So that becomes a u dash differential. Okay, now differential of ln x is 1 over x. It's a special case, if you remember. That's a special case. So I got this bit done. Now I need to integrate the other side. So this side I need to integrate. That will be now when you integrate, the way we integrate is the rule of the integration is whatever the power is minus 2, you add 1 in the power and divide by the same thing. So this thing will become x minus 2 plus 1 divided by minus 2 plus 1. So that will be x minus 1 over minus 3?
No, minus x to the power of minus 1.
Yeah. So minus x to the power minus 1, yeah? Thank you. Okay, so we got this one. Thank you, Roman. So you're not going to get extra marks in exam. Okay, so you got this way. Now I got the everything. I would put this in here. Let's do this one. So I got u and v. So I'm going to do that one here. Let's write it down. ln of x 1 over x squared d of x. Okay, so I will put that one. What is u? U is ln x. ln of x. What is this thing? This, I already done that one. Minus x to the minus 1. So minus x to the power minus 1. What's the u dash? 1 over x. Thank you. 1 over x. Okay. What is this thing? Minus x to the minus 1. Okay. Now let's sort out this side. I don't need to do anything. So let's have a look at that side. This is becomes a minus ln x. I put the minus out and x minus 1. I will simplify it in the next step. This becomes this minus and this minus becomes a minus and a minus. 2 minuses out. I will do that in a plus in a minute. 1 over x is here. That thing copy paste. And this becomes a x to the minus 1 d of x. Now this minus and minus makes a plus. Now let's do that one. Minus ln x. X minus 1 is same as 1 over x. Yeah. This x minus 1 is same as 1 over x to the power 1. We don't write the 1, but I'm still writing it. This thing becomes 1 over x, and there's a 1 over x here. Thank you. 1 over x times 1 over x is 1 over x squared. So I'm just going to rub this thing. And I just put a square there. Yeah, I put a square there. I can also, with that square, I can also do this. X minus 2, because square goes up, becomes minus 2. Yeah. Okay. Law of indices. Let me just put this one close. Okay. Now this thing becomes a minus ln x over x. Yeah, because this x can be written underneath. This thing becomes, the way integration we do x minus 2 plus 1 over minus 2 plus 1 plus a c. So I need to do one more step and then that's it. Let's do that one here. Minus ln x over x. This becomes a x minus 1, x minus 1 divided by minus 1. And there's a plus. Yeah. Minus 2 plus 1. This minus 1 and plus 1 becomes minus. So that becomes a minus. Now, then this is x minus 1. I can bring it down. This x minus 1, I can bring it down. And that will become a 1 over x. Yeah, and obviously there is a c in the end. There is a c, but I will write the c in the middle. Now, if you see there is a x, 1 over x, 1 over x. If I take 1 over x common, I got minus ln of x minus 1. Let's put the c here. Actually, I put the c here, so let's put the c here. So this is the answer. Oh, it's just one thing. How can I integrate? There is no u, there is no v. Yeah, but there is. It's invisible to your eye. Okay, let me rewrite this question again. Dot, then there is a 1. So now we can have our u and we can have our v. If I look at this liate, L-I-A-T-E. Now on this, oops, you can't see. Okay, on this one, logs, it's a log, ln is a log, is my u. So let's use that one. U is ln x. So what's the v then?
1.
V is 1. What do we do with the u? We differentiate. We don't like. Always remember. Yeah. U we differentiate. V we integrate. I'm not writing integrate with respect to x. So let's do the integral. What's the integral of the ln x? Remember, ln x is a special case. Yeah. So the integral of ln x is 1 over x. So now you can see I'm skipping the steps. Yeah, I'm not writing du over dx and d over dx of ln x. Yeah, I'm doing that one. So at this stage, you can do straight away. But in the previous one, where the question is only differentiation, make sure you do all the steps. Integrate. So integrate. I'm just going to do that one because integration is a little bit tricky. So that will be how much? X, isn't it? Integration of this thing is an x. So I have two things. I have that thing and I have this thing. Okay. Now I'm going to put that in this formula straight away. So I'm just going to start from, let's say, from here. Let's cross this line. So let's say this is there and I'm starting from here. U is ln x. What's this v integration of the v? So I'm going to put dot x minus, what's the u dash? 1 over x. What's this thing? X. Now this x, and we can cancel them out. Cancel, cancel. So here you got just a 1. And here you got ln x dot x. Usually the real way of writing this one is we write the x in the front. Yeah, it looks nice. Because otherwise I would say like this ln x squared. No. So I got this bit. Now x ln x. What's the integration of 1? X plus a c. So this thing has converted into this monster. You know, a tiny thing becomes big when we integrate. Big. So that's how we do the integration of ln x on its own.
You get a reference.
I will put the link. Click. Okay. Now, okay, which one is u? Which one is v? Can someone help?
U is e to the x.
U is e to the x. Okay.
Isn't it the algebraic?
Okay. U is e to the x and v is the x. Yeah, that's what you say. Okay. Now, if you guys, if you have a look at this bit, if you have a look at this one, have a look at exponential. Exponential. Exponential is supposed to be the last one to get the. Yeah, but no, you did right. There is something going on here. So let me do that one this way. And if it doesn't work, it will work actually. But if it doesn't work, we go the other way and we see what happens. Okay, so this is x squared. And let's see what happens. So this one I need to differentiate. So differentiate. What's the answer? Okay, so the only thing that happened is you, yeah, that's okay. Integrate. that would become how much?
X cube over 3.
Yeah, I'm not putting plus c. Okay. Now, I will upload here and I will see what happens. When I say upload, just put that one here. What's the u? E to the x, and this thing is x cubed over 3. Yeah. Plus, no, sorry, minus. What was the u? E to the x, and this is how much? X cubed over 3. Now you see what happened? I start with a really easy one. Yeah, and I got this one. This is fine. But now I got even more complicated one. Yeah, I got more complicated one. Next time I'm gonna do that would be x4 over something, x5 over something. I'm just complicating it over and over and over and over. So I need to actually sort this thing out. It means this thing doesn't work. So this is what I say, like you will straight away figure it out when you do it's wrong. Yeah. Okay. So we can't actually do that one. So let's have a look at this bit where we change the u and the v based on that bit. So this is incorrect. So let's have a look. U is, and that is yeah. This. So u is my x squared. Let me clear that one because we made a mistake. U is x squared. Based on that one, algebraic is the u. Exponential is that one. Okay, when you integrate that one, that's still an e to the x, isn't it? Yeah. But this thing is going to reduce to how much? 2x. 2x. Now let's put that one here. Let me just put the boundaries. Let's put that one here. Okay, what's the u? X squared. And this thing is e to the x. So that's fine. Minus, what is the u dash? 2x. I can write the 2x here like that, or I can bring the 2 outside, much easier, but we do that in next step. And this thing is e to the x. Now you can see it was x squared. Now that is as it is, x squared e to the x as it is. Now just take the 2 out and you got, now you see this thing has been reduced into that one. One more time, I have to use that rule, and that's done. Now, I still have to do this bit. So now I'm going to do another u, another v. So this one, I'm going to do that one again. So in this one, what's the u? U is the x, and the u dash is just 1. V is e to the x, and is e to the x. Now I need to apply the formula again here. So when I use that formula, this one again, what's the u? U is just an x, and that is e to the x, minus u dash is just a 1, and this is e to the x dx. Now this x, e to the x remain as it is, minus this is just an e to the x, differential of that one is there, plus a c. Well, I don't want to put the c now. I will put the c later.
Can we take e to the x common?
So it's again?
Can we take e to the x?
E to the x common? Yes, yes, in the super end. Okay, so here I got the x squared e to the x minus 2, a bracket, then whatever the answer is, that was the answer for that one. X e to the x minus e to the x. Now, if I open up the bracket, x squared e to the x minus 2x e to the x minus, no, plus 2 e to the x. You can leave it like that, or there's e to the x common. You can take e to the x common, and I got x squared minus 2x plus a 2. Don't forget the c. Yep, this is your answer for that question. So sometimes you have to do it twice, but see, the x squared becomes the x, and the next thing x becomes just a 1, and the next was the answer. So if we do the other way, you are increasing the power. X squared becomes x cubed will x4, and so on. It will never finish. Okay, now let's say we got exponential and a trig. U, according to that lineage, U is going to be the cos x, and V is going to be the e to the x. So we differentiate. If cos 2x, I'm differentiating the cos 2x, the answer is minus sine 2x, minus sine 2x. And then whatever number is here, 2, just bring it outside. If that was 7, I put the 7 outside. Now I'm going to integrate this thing. And you all know the integral of that one is exactly same. Okay, I'm done with that bit. Now I'm going to use the formula, which is that formula. So I got the cos 2x dot e to the x minus u dash is that minus 2. You see this minus 2, I bring the minus 2 here, minus 2, and then I just put a sine 2x. This minus 2, the minus 2 from here, I put it outside. And then I got that bit, which is e to the x d of x. Okay. Now, let's simplify. This becomes the cos 2x dot e to the x plus, this plus, minus plus. Can I write this one as e to the x dot sine 2x? Same thing, yeah? I just changed the position. That's what I did. I moved that one here, that one there. That's it. 5 times 2 is same as 2 times 5. You can write it. Now, if you have a look, I started with the ex cos 2x. Now, I got this bit plus I got that bit. Now, if I do that one again, I will have cos again. Then I do it again. It will be sine, cos. So they will keep going on and on and on, never ending. How do I end this thing? Let's have a look. Now, I need to do that one separate here. Okay, let's do that one. In this one, which one is u? Sine 2x. Sine 2x is u. So u dash is going to be how much? Cos 2x. Now, v in this case is e to the x, same thing. So I need to integrate this thing. It's going to be e to the x. There is a 2 here. Yeah? Okay, yeah, there's supposed to be 2 there. Okay. Now, when I got that bit, I need to do it again. I need to put that in this formula again. So let me just get rid of that bit just to create some space. So this thing will become, according to this rule, the u is sine 2x. And the v is e to the x minus u dash is 2 cos. So let me put the 2 outside, yeah? And then I got the cos 2x. And the other thing is e to the x. D of x, yeah? Okay. So I'm going to rewrite this thing. That is sine 2x e to the x minus 2. Let me rewrite this thing. This is e to the x, and this is a cos 2x. Now, if you have a look, I arrive at the same thing again. If I keep doing that one, that would be something minus 2, this thing, dot sine. I do that one again, something minus 2, this thing, cos again. So it's going to alternate between sine and cos, sine and cos, sine and cos, never ending. So how do we do that one here? Now, when we got this bit, let me first write this thing here, or the integration of this thing is already here. So I can just put that one. Let me just put it back. I'm just going to put it back, this thing in this equation, and we see what we can sort out. So if I put that in this equation, I got the, okay, let's do it. So now this one, the answer is I'm going to put in this equation. So I got the cos 2x e to the x. Usually write e to the x first, but doesn't matter. plus 2. The answer for this thing is here. Sine 2x e to the x minus 2 e to the x cos 2x dx. Yeah. Let's open this one up. I got cos 2x dot e to the x plus a 2 sine 2x e to the x minus 4. 2 and 2 is a 4. 4 e to the x dot cos 2x dx. You can see I can't cancel anything, but I need to sort this 4 out. Okay, if you write it down, please. Okay. Now, this is, what was the question? The question was this thing, isn't it? So I'm doing e to the x dot cos 2x dx. Yeah, so that's supposed to be dx. Okay, now you see this thing. You see this thing is here, and you see this thing is here. Why can't I bring this thing back on this side? Let's bring this thing back on this side, and let's work it out. So there's a 1, that's a 1 e to the x, and there's a minus 4. When minus 4 comes there, that becomes a plus 4. So this thing on this side, it will be a 5 e to the, sorry, 5 integration e to the x cos 2x dx equals to cos 2x dot e to the x plus a 2 sine 2x e to the x. This 5, I don't want 5 of that one. I want just one of these ones. So this 5, I'm going to rub from here, and I'm going to divide on the other side. So I can do either 1 over 5 like this, and done. Or I can divide everything by 5. That's it. That 5 on the other side become 1 over 5. And that's the answer. So you need to actually do it twice to get that thing again here. Doesn't matter that symbol. And then put it on right side, left side, and then just simplify. You will get a number here. And divide that by number here, and that's the answer. So we were doing it right. Otherwise,
Progress.
okay, 2 tricks. So what we're going to do with 2 tricks, let's have a look. I need a u. So I'm going to call sine x as a u. So I need to do the u dash, which is actually a cos x. Differentiate this bit, cos x. My v is cos x. So I need to integrate this one. And that integration of that one is a minus sine x. Okay. Now I need to put in this main equation. So let's do that one here. U is sine x. U is sine x. This thing is minus sine x. Then the u dash is the cos x. And the v is minus sine x. Minus sine x. Okay. Sine x becomes a sine square x. Remember there was a minus here. This minus comes outside here. Now this thing, this minus and this minus becomes a plus. And
the integration of the cos x sin x.
Integration of cos x is, oh yeah, it's a positive sine x. Sorry, thank you. So that's a, yeah, it's the other way around. Yes, so that's a positive sine x, which means that will be a negative. So that thing becomes a sine x cos x. I'm just changing the order. Doesn't matter. Sine x dot cos x d of x. Now I'm stuck here. If I do that one again, because this is the real question. This is the real question. So I'm going to write it again. Let's write this question. The question was, do this sine x dot a cos x, and I got the answer. The answer was minus sine square x minus integration of the sine x dot a cos x d of x. Okay. Now this thing is a negative here. This is exactly same as that side. So I'm going to put on this side. So that becomes a copy this thing. Sine x cos x. This is negative. On this side becomes a, sorry, that is a d of x as well. On this side it becomes a positive sine x cos x d of x is minus sine square x. I haven't put plus c. I will do that in the very end, but make sure you do. Okay, now they are same thing. One same thing plus another same thing is a two same thing. So 2 sine x cos x, and this is that, and this is that, equals minus sine square x. Okay, this 2, I don't like the 2 here because the question is asking me to do 1. So I'm going to pick up this 2 and bring on the other side. So this 2 will disappear from here, and it's going to appear on this side. Yeah, you can do that way or you can do full line. Doesn't matter. You know, still the same. Usually the way I do it, I just do up to here. Don't forget the plus c. Now you might be thinking the c, I have to still divide the c by 2. If let's say c is million divided by 2 is still a constant because we don't know what's the value of the constant. We can figure out, but we still don't know. So I'm just going to put like 2 here. You can do c divided by 2, which is another constant d. Doesn't matter. So this is your answer for this. Okay, I made a tiny mistake. Okay, I mean that should be a positive here. So that should be a positive here, which means that should be a positive here, and that should be a positive here. So that should be positive. Yeah. So that's the answer. It's a positive. Yeah, because I wrote that one incorrect initially. So we got that bit. Now the other answer can be a minus half cos square x. And that's still the same. The reason the answers are different is it depends on which one is u, which one is v. And if you take the u as sine, this is the answer. If you take u as cos, it will be minus half cos square x. Yes. So in differentiation, the answers can be different, but both give you the same kind of result. Integration of ln x divided by x cubed. So rather dividing by x cubed, I'm writing 1 over x cubed. Yeah. Now, based on that thing, the Lie log inverse algebraic trig exponential, you need to figure out which one is u, which one is v. So what's the u in this case? U is ln x. What's the u dash? 1 over x, because ln is a special case. What is v? X minus 3, isn't it? Yeah, because 1 over x is same as x minus. Okay, so what is that one then? X
power 2 over minus 2.
Yeah, minus 2 over minus 2. Yeah, yeah. Happy then? So we plus 1. Yeah, minus 3 plus 1 minus 2, and the minus 2 here. I just put the minus here. Okay, I got that bit done. Now let's put in this one, this equation. What is u ln x? What's that bit? That one. Minus x minus 2 over 2. Oh, we can simplify that later. What's the u dash? 1 over x. What's this bit? It's a minus x minus 2 over 2 d of x. Okay, let's sort this one out. This minus I can bring at the actually. Yeah, this minus I can bring at the front, minus
And 1 over 2.
ln x, and this 1 over 2, yeah, so I can put the 1 over 2 here as well. Yeah. This x minus 2 comes here, becomes x squared. Yeah. So 1 over 2x squared, or you can write it like that way. ln x divided by 2x squared, and this is a negative here as well. Minus, let's do this one. I'm not integrating, I'm just simplifying now. This is 1 over x, this minus and this minus becomes a plus. And this becomes a 1 over 2x squared dx. Now, that one as it is, I can write down minus ln x over the 2x squared. This thing becomes a x,
1 over 2.
yeah, 1 over 2 outside of integration, and you got 1 over x cubed. 1 over x cubed is same as x to the power minus 3. Yeah. So if I do that one here, 1 over x cubed d of x is same as x minus 3 d of x. If I integrate that one, that becomes, you only done that one, but let's integrate that one. That becomes a x minus 2 over minus 2. Okay. So in R, if I simplify that one, that becomes a 1 over 2x squared with a negative. Now I'm just going to put that thing here and we see what answer we get. Minus ln x over 2x plus 1 over 2 and then minus 1 over 2x squared. Yeah. And if I simplify this thing,
Please, that's 2x squared.
this one?
Yeah.
Yeah, thank you. So now if you have a look, let me simplify first. Minus ln x over 2x squared minus 1 over 2 times 2x squared. Now you see these are 2x squared that one and the 2x squared that one common. So I can take 1 over 2x squared. I don't want to take negative off, just like that one. And I got minus ln of x minus 1 over 2, and obviously there will be a c in the end, and that will be your answer.